Autocidal approaches are basically using an insect against itself. So in this case, we're using male mosquitoes to deliver a pesticidal effect to impact and hopefully reduce the mosquito population. So autocidal means self-killing. And so basically, yes, using the mosquito against itself. And so at the present, we have received permits from the Environmental Protection Agency, which are allowing us to do field trials. And the hypothesis that we're testing is twofold. First, we're looking for efficacy to demonstrate that releases of these male mosquitoes, and importantly, I think everyone that watches this should know, but male mosquitoes don't bite. They don't bite, they don't transmit pathogens, they don't blood feed, and so it's just the females that are blood feeding. So we can release the males without risk of disease transmission. But the question is, by releasing these male mosquitoes, can we reduce a mosquito population? And then the second question is also safety. And there's a number of risk assessments that we're addressing for the EPA to look for things like unintended establishment of Wolbachia in the population, non-target effects, and things like that. So actually, I'm a bit of a cheater because basically I'm just taking advantage of a natural system. So Wolbachia, over millions of years, has evolved the ability to manipulate the reproduction of its host. So I'm cheating. I don't have to create anything. I just take what Wolbachia has already generated. So what we have done is developed a way to move Wolbachia around to create artificial infection types. And that allows us to basically manipulate this sterility effect and take advantage of a system that has evolved naturally. So we have essentially a little mosquito factory where we are, literally rearing millions of mosquitoes and then removing the females and releasing the males. So we're calling it the atom approach, and the idea is, again, we're releasing male mosquitoes that don't bite, but in this case we are dusting them with a very powerful, it's a pupacide, but basically it prevents the development, successful development of immature mosquitoes. So it really doesn't have any effect on the adult males, but it's very powerful against immature developing mosquitoes. Many people don't understand that immature mosquitoes are in water, they're aquatic, and so this, when the males are released, they are delivering this dust, this pyriproxyfen, and depositing it into the water, which then kills the larva. And so that's the idea. Again, it's the same idea as I mentioned before. It's using the mosquitoes to kill mosquitoes. And an advantage of this is that instead of me having to go into someone's backyard and find every breeding site, male mosquitoes are very, very effective at finding both breeding sites as well as contaminating other mosquitoes, say females, during mating attempts. Yeah, if you come up to a person and you ask, may I release 10,000 mosquitoes in your backyard, you can imagine their expression on their face. But then one of the most surprising things about what we've been doing is how readily people accept and adopt the technology. Once you explain to them that male mosquitoes don't bite, and that these males are essentially going to mate with females in their backyard and cause this form of incompatibility and hopefully reduce the population in their backyard. And really, one of the biggest reactions we receive is from people who say, you should come to my backyard and do this work. Don't do it over there. Come do it here with our yard. We are testing and collecting data for these two autocidal approaches with the goal of providing this data to the EPA in the hopes that we will get registered a new pesticide against mosquitoes, new methods for controlling mosquitoes. This should not be thought of as a magic bullet. These are not going to replace existing methods, but essentially these are going to be additional tools, ways to augment and ways to be integrated into existing methods to allow for further suppression of mosquito populations.